Welcome back to another Solidworks tutorial. For part 2, we will be doing the bearing drawing. You can see in the drawing here all the dimensions that you need to apply towards the part, and we'll be creating the part here shortly. So what you'll want to do is go ahead and draw this circle right here and draw a line that's tangent and draw this line over here that's also tangent, and these two are tangent as well, and you can see that's what this right here is. And then when you come in here and do the arcs right here and here, everything will snap together. The only thing that's left is the length of this, and that's actually not provided in the sketch. So you just kind of have to look at the drawing and guess where the holes are supposed to be located. It's just kind of eyeballing it. I think that's about right there. So what you could do is, let's see if we can add relation. I always set these all to be equal. And we'll set that one equal to that one. That way they don't move in a really weird way, but it's still the width here that's going to be a problem. So trying to do center to center like that. And I don't know, we're going to just pick a number arbitrarily for the moment. And you can come back later and edit this as you'd like to get the shape to look a little bit closer to the drawing that's provided. See, typically the drawing would have that center to center dimension, as well as the thickness of the plate itself. Neither of those are provided here. So we just have to guesstimate here. And then there's that center circle here. That's going to be the hole. And then what you want to come in and do when you have this circle, you'll use trim entities and keep the trimmed entities as construction geometry. And you'll come in here and you'll trim the top of the circle here and like right there, and then down here and down here. And then that'll just show the construction line, but it's not an actual sketched line. So you just go up and hit the check, and there's your base. Get into this step right here of extrusion, and I just hit blind and half an inch. Just kind of eyeball the picture and go with that. So hit the check, and there's the bottom of the bearing block. The next component is another extrude. So you want to start from this surface, and you'd hit normal 2, and you'll do an extruded boss with that surface. You could draw the circles. I'm going to use convert entities here and just draw that circle. And then we'll do the second circle. If I can get it to snap. There we go. Is it going to snap? No, it's not. Let's see. Add relation to that and co-radial. Okay. So there's this circle. And this circle is basically an entity off of that. We'll hit the check and see, we'll start extruding it. See if it tells us how tall this is. It says 2 inches tall. So 2. So there's your extrusion. So starting to look a little bit more like the drawing. And we have this 1/4 inch cut right here. So come in here, normal to with an extruded cut, draw another circle like so, and the dimension of that is 2 inches. And hit the check, and the cut should be a blind, but it will be, we do 5, and you hit the check, and there's your step. So there's a few rounded features here. So if you come to the right plane, hit normal to. So with the sketch that's shown, we've got a fillet on the corners here, and there's another fillet that kind of just fills in this spot right here. And they're all radius 0.125. So we can come in here and let's see if we can show this. 0.125. So there's our first fillet. And then our second fillet be that edge and that edge. And you could have put them together. So like if I back out of here and edit this fillet, you could have selected that edge and just had that all merged together like that. So if we do, there we go. And yeah, so that's exactly what you see in the cross-sectional view of the drawing itself. So let's show kind of like that. So you got your fillet right there, you got a fillet here, you've got this cut. The last two things the last thing we have to do is add our holes that are over here and here. And I'll show that in just a moment. Just go back to that, turn this off, and then we'll show these holes. Let's see. I'll use Hole Wizard, and we want a hole with a counter bore to it. The size of the hole is 375. The counter bore is 0.625. So 375 is 3/8. See, there's all sorts of screws you can tell it to use. We're going to be using a pan slot head. And position be along this line right here. Custom sizing. So if we change this, our hole is 375. 375. And our counter bore is 625. And the depth of the counter bore is 0.125. And then you'll hit the check, and there's your hole with your counter bore, and we would mirror that across the front plane to the other side. And so really all that's left here is to make sure that you align this hole with your center of the circle. So if we revisit the boss extrude, go back to the sketch. So the center point is right there. We'll just kind of sketch a line like so. We can sketch. This one's going to be for reference because it's mirrored, so it'll do the same thing on this side. And for construction, we're just kind of trying to show that point. And we go there, and then we edit this feature position, so we just need to show the sketch of that. So I basically brought down the menu. So while you're in hold position, you'll open this menu right here and find the sketch for your initial extrude, and your construction lines show up. You actually have to show the sketch, and you can snap that to the line that we just created, that cross right there. And that's your position for your hole. We can hide this sketch now and hit the check, and there's your hole positions. I think the center to center is a little close, so we'll revise that. Maybe try 375. That looks a little bit better. We'll roll with that. So there's our part. So looking back on the drawing, the dimension of the bearing holder, you could call it, that's sticking out, that we said was 2 inches, it's actually taken from the base of the part to the top, not from the top of the surface. So we gotta go back to the extrude and correct that. So we said this is a 1/2 inch thick. So what we need to do is say 2 minus 0.5, and it should correct that. I mean, that's 1.5, but if you had some complex dimension, that's how you would do that. So now the height of it looks correct. So there's our part. We can save that, create a new drawing from part assembly, and find your template, hit OK, and then we've got a top view and a cutaway. So bring in your top view, and you can hit escape. Just bring in section view, snap it, right click, slide that over, and here we'll show all of our dimensions. Let's see, we've got, what is going on with this? We use smart dimension that, that one, and that one. We have this outside and this inside. It says 3/8, so let's change that to 375. And basically all I did here was come into the dimension tolerance, and you change it from the default 0.12 document to 0.123. And that's how you get it to show 3 decimal places. And for all of these, we'll fix the leaders to be horizontal. And let's see, these leaders should be pointing on the outside, so we got to correct that for all of them as well. This one I will change the decimal to, no, let's keep it 1 decimal. And this one can be 1 decimal. And this one could be 1 decimal. Just kind of cleans it up a little bit. This one should be 3 decimals, 0.625. Okay, and so that gives us all of those dimensions. Then we need to show our height of this, which was 2. Well, we've got the height of this, which we said is a half. There's this thickness here, and there's, if I can show it, oh, didn't like that. I have to zoom in to get this to show. Basically, I'm trying to show the thickness of this feature right here. It should be 125. And we're just kind of clean that up a little bit. Cleaners, arrow. Okay. And let's see if there's anything else we're missing. Oh, there's a hole that we missed. We've got this right here. And also the scale is 3:4, so we have to revise that and say 3:4. That made everything bigger. So we just need to move everything around, make it all fit. And let's see. Let's keep that like so. That kind of shows it right here. Show this dimension. I don't know why it's snapping. There we go. And we just update our fonts here, fix everything. I like to use 12-point font, so change that, change this. Yes. And so we have to go back and add the whole feature that's on the side, and we'll have to update all the information in the model for the title block. So let's go ahead and do that. So going back to the model, we've got a hole. There's not really a height to this. I mean, it says 125, but is it 125 from the top or from the bottom? Let's try 125 from the top and see what that does. Is it through and through? No, it's only on one side. So we'll take from the plane, normal to, it'll be an extruded cut, and it's just a circle. And the diameter is 0.25. 0.25. And we'll take it from the top here. See what 1.25 shows us. No, it's not that. So let's get rid of that dimension and try again. I think it's from the bottom. Just, it doesn't really show it very clearly in the drawing. So 1.25. Yeah, that's a little bit better. I hit the check. And obviously it's not cutting yet, so you have to do up to next. And it'll cut the one side that you want. And there's your hole. So make sure you save this. And we'll do the properties next. It's a little box with lines right here that say file properties. And you open that up and you'll just start adding properties. So we've got material, we've got weight, we've got unit of measure, we've got a description, there's a drawn by and a drawn date. Where's that drawn date? So material can snap to the model, you can pull it directly. The weight is the mass, and then the rest of this is manual entry. So units of the measure is IPS. The description, we're just use CPCC. Drawn by that, and 121.24. That's all the information we'll get here. Let's see if there's anything we can show extra. So unit and scale are the last two. I believe those are, so we've got unit of measure, that'll populate correctly. Scale's the last one. That'll pull from the properties of the drawing itself, not the model. And then finally, we'll have to set this material as gray cast iron, so let's hit the OK. And material, edit material, gray cast iron. And apply and hit close. Make sure you're saving along the way. Now that you have your material put in, and we have the hole, and we did the file properties, you can go back to the drawing, and it'll regenerate everything. Your hole showed up just now, your gray cast iron showed up. Most of this stuff right here populated. Let's see, why did author keeps doing that? I'm not sure why that one doesn't want to work. So let's show the dimension for the hole we just added. It's from the bottom to there. And we can just show like so. And try to show an arrow there for this dimension. And okay, and that's it. So I've gone ahead and entered into edit sheet format. Author, my template seems to be broken, so I have to come in here, hit the properties, model found here, and see if I hit drawn by, there's the evaluated value, and it just kind of showed up. So we're going to hit the cancel out of that, but we need to edit the scale. So go back to link to property, and this time we'll use it out of current document. And let's find the sheet scale. And then I'll hit OK. And that should be it. So yeah, everything populated. And there's your drawing. Let's make sure one more time if we're missing any dimensions. Are we missing any dimensions? If we do that, we can show the lines, but I'm trying to not use parent. There we go. So I was trying to show the dotted line. So this one right here, if you show the display style, it's hidden lines visible. It shows the whole. But if you come to this one, you could have seen all the fillets and stuff. What you want to do is just kind of scroll down and find display style and uncheck use parent style and go back to hidden lines removed, and it cleans it up correctly. So the drawing is done like this. Make sure that you're saving along the way. So next will be part 3. We'll be creating the next component, which is the base plate drawing. Thanks for watching, and make sure you like and subscribe for more content.